Earlier in the semester, we looked at a formula called the simple interest formula, where we saw that interest was equal to principal times rate times time. And we used those when we were looking at linear equations. In this section, we're going to look at a new formula called the compound interest formula. And this, because t is an exponent, is going to be an exponential function. Compound interest is when you have your principal, your capital P, that's also called your present value, because it's the amount of money that you have to start with. And then A is going to be the amount you have at the end after the time has gone by, also called your future value. Lowercase r is going to be the interest rate. And we're always going to express the interest rate as a decimal. T is the time in years. And M is the variable that tells us how often compounding takes place. So M is going to be the number of compoundings per year. So if I have an amount of money, P, capital P, and I place that into, say, a savings account, getting a certain interest rate, let's say that it's compounded monthly. That means that at the end of the first month, the interest just for that month will be taken on the original principal and added back in. So when the interest is taken again at the end of the second month, you're taking the interest just for that month over the original principal, but also over that little bit of interest you've already made. So that interest is constantly being added back into the principal, and it's growing a little bit faster than if it were just being compounded one time a year. So M is the number of compoundings per year, and it doesn't matter how long the T is, those are separate variables. The M is the number per year. So if it's compounded once a year, annually, M equals 1. If it is compounded twice a year, that's called semi-annually, M is 2. If it is compounded quarterly, that means 4 times a year, so M is 4. Monthly, there are 12 months in a year, so M is 12. Weekly, there are 52 weeks in a year. And then daily, there are 365 days in a year. Sometimes it is stated to use 360 for daily. And of course, if it does state that, use 360 rather than 365. So these numbers for M are not going to change. If it's quarterly, M is always 4. If it's weekly, M is always 52. Because the time, the T, is a separate variable. Let's look at some examples of this. Let's say that I want to, how much money would I have after 7 years at 2.3% interest compounded quarterly. If I started with $5,500. So we know that we are using the compound interest formula because it says compounded quarterly. In a later lesson, we're going to look at continuous compounding, which uses a different formula. So I need to figure out what each of these statements is telling me. So if I say, how much money would I have? That's saying, how much money will I have in the future? So that's telling me that the future value, is what I'm looking for. It's what I don't know. After 7 years, that's my time. Time is 7. At 2.3% interest, that's my interest rate. And I don't even want to write 2.3% down. I want to go ahead and put 0.023. Remember that if I have 2.3%, percent means out of 100. So what that does is it moves the decimal 2 places to the left, which gives me 0.023. So just write the decimal down on your paper rather than the percentage, and that way when you're plugging it into the formula, you're not as likely to plug in the wrong number. And then compounded quarterly tells me that there are 4 quarters in a year, so M is 4. And the amount of money that I started with is present value, capital P, is $5,500. So I recommend that you actually write each of these variables and what they're equal to, including what we're looking for. That's like identifying your variable, because we're going to see later that we'll be finding different ones of these variables. And because it's compounded quarterly, I know I'm using the compound interest formula, so I write that down on my paper. And then I plug in all of my numbers in the appropriate spots. And I'm going to go ahead and put this exponent in parentheses. And that will help me remember when I'm plugging this into my calculator that I cannot use a double parenthesis here, because I cannot use that, because that would have it take it to the 4th power and then take the whole answer and multiply by 7, which gives me an incorrect answer. So plugging this into my TI-83 calculator, I'm going to plug in 5,500 parenthesis 1 plus 0.023 divided by 4, close parenthesis, and I don't need parentheses around that. It knows to do that division first, caret for my exponent, and then 4 times 7 in parentheses, so it knows to multiply the 4 times 7 before it takes the exponent. So I want you to practice entering all of this into your calculator all at once, rather than doing little bits of it and then plugging it back in, because you're way more likely to get rounding error there. So when we plug this in our calculator, 5,500 parenthesis 1 plus 0.023 divided by 4, close parenthesis, caret, open parenthesis, 4 times 7, close parenthesis, enter, and I'm going to round this to the hundredths place because we are talking about money, so we're going to round to the nearest penny. Okay, I'm going to go ahead and write another paragraph here, another question. And then I want you to try to model what I just did and solve this one. And this time I'm going to borrow money. And it turns out that we're using the exact same formula. It doesn't matter if you are putting money in and gaining interest, or if you are borrowing money and ending up having to pay interest, because that's two sides of the same transaction. So this time I'm going to borrow money. I am going to borrow $10,000 at 1.8% interest for 5 years. 1.8% interest compounded monthly for 5 years. How much will I owe to pay back the loan? And I'm just going to borrow a lump sum at the beginning and then pay it all off at once at the end. And so I'd like you to do what we did on that other problem. I want you to identify each variable, write it down, P equals, R equals, etc., including what we're trying to find with the question mark. Write the formula, plug all the numbers in, put it into your calculator all at once, write your answer, round it to the hundredths place with units. So go ahead and pause your video, do those things, and then turn the video back on when you're ready to check. So we see that I'm going to borrow $10,000. That happens at the beginning, so that is my capital P. Compounded at 1.8% interest, so that's my interest rate. And I move my decimal to the left 2 places, 0.018. Compounded monthly. There are 12 months in a year, so M is 12. I'm doing this for 5 years, so T is 5. And how much will I owe to pay back the loan at the end? That is going to be my A that I'm looking for. So I write my formula. I plug in all of my numbers. I plug that into my calculator all at once. 10,000, open parenthesis, 1 plus 0.018 divided by 12, close parenthesis, caret, open parenthesis, 12 times 5, close parenthesis, enter, and I have that I will owe $10,941, and I have 0.005, and I'm rounding to the hundredths place, and this is 5 or more, so that moves over 1 and gives me 0.01. I'm rounding up because the third decimal place is 5 or more. So my answer is $10,941.01. And if I wanted to find out how much interest I owed, then I would take my A, the amount I had that I owed, and I would subtract the amount I borrowed, and I would see that I had that I paid interest of $941.01. So that's using the compound interest formula. Anytime a formula or anytime a problem says compounded monthly, daily, weekly, etc., I know that this is the formula that I'm going to use. In our next several videos, we're going to look at another exponential function, another exponential model that uses continuous compounding.